All right, guys, since we only have a little bit of time, it's a short day, we're only going to do this one, okay? The perimeter of a triangle ABC is 28 inches. Find the length of side AB. Does anybody know what we need to do first? So this is 2x minus 6, and this is 2x minus 6. So we need to figure out what x is first, right?
You gotta take this out.
What do we know is in front of this x? Huh? 1. All right, does this look more familiar? All right. What are my common things that I need to add together?
Come on, y'all. What are the like terms?
That's the word, like terms. The x's, okay. So 2x plus 2x plus 1x is what? 5x, thank you.
Don't be afraid to use your fingers and your toes.
Yeah. Then what else? What's 6 plus 6? Y'all know this.
12.
Thank you. Now what do I need to do?
How do we get x by itself, y'all? How do you do that?
Y'all know this one.
What goes first? Do we get rid of the 5 or do we get rid of the negative 12?
Negative
The
12.
negative 12. How do you get rid of a negative 12?
Adding. Good. If I add on this side, I have to do it on what? The other side too. Good job. And this does what?
What's negative 12 plus 12?
Cancels out, right? 0.
0.
What's 28 plus 12? Somebody tell me. 40. Good. I'm right over here. To get 5 by itself, what operation do I need to do?
Is it addition, subtraction, multiplication, or division?
Division. Good job, Andre. Why? Because this is what? What do we know this is? This is multiply. Yeah, I got what you're saying. So we got to do the opposite, right? And that does what? Cancels out, yep. What's 40 divided by 5, guys? Huh? Good job, Sammy. X equals 8. Are we done? No, because it's the question asking for what x is. No, we got to plug it in. How do I plug it in for this equation? 2, what do I put for x now? 8 minus 6. What's 2 times 8? 16. Thank you, Alex. 16 minus 6 is 10. Good job, Alexis. So how long is what is the length of side AB? 10. Good job.
Make sure that we write down what our homework is tonight. We got Wednesday homework. Turn to the front of the packet. Turn to the front of the packet so you can write down Wednesday homework. Okay, so the agenda is on the board. We've already taken care of the warm-up. Ms. Peoples did the warm-up for us today. Thank you so much. And then I'm going to go over creating perfect roots. Creating roots, or perfect roots, sorry. And then we're going to estimate some roots, okay? Estimating roots. I wanted to do that on whiteboard, but we're going to play it by ear. We have our Wednesday work. Don't forget that our homework help video, where is our help video located? Canvas and Remind, okay? This is video, I'm sorry. My letters are kind of wonky. I'm going to pause to give you a chance to write. Please write your homework in your planner. Okay, so in your planner, today is Wednesday. Yesterday was Tuesday. If you watched the video yesterday, check it off. If you completed your homework, check it off. If you reviewed your multiplication facts, check that off. Wednesday, Math 8. Got math again. We have watched the video. We have complete homework. And we need to review our multiplication facts. Review notes. Okay. We have a quiz on Friday, how to put numbers in order from least to greatest. So we need to make sure we understand how to convert to a decimal. And then we also are going to be categorizing numbers. You need to know the difference between real number, whole number, natural number, irrational, rational. Okay. I'm going to pause. I see some people still writing. Please write this down. Do you have this written? Where's your planner? Tamir, where's your planner, babe? Get your planner in. All right. Take out your interactive notebook, your composition notebook, please, so we can finish creating. Are you cold? I thought you said you were cold. I can hear you. Where's your notebook? All the time in the morning. Why do y'all do this to me? Because why do y'all do all this stuff? Go get it. But you can't do that every day, okay? Hurry. All right, everyone should have their calculator. If you don't have your calculator, please pick that up. All right, let's continue with making or creating the perfect squares, and then we're going to create perfect cubes, okay? So for our perfect squares, we're going to go all the way to 20. We need to know all the way up to 20. These are the ones that I need you to study. Your 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way to 20. Okay, that's all right. Make sure you try to find it, okay, babe? We're going to go all the way to 20. So let's do the next one. We got the next perfect square to create. We're going to say 10 times 10. What's 10 times 10? 100. 100 is a perfect square. So we're going to find the square root of 100. What is the square root of 100? 10. Why? Because 10 times itself, just write it on a piece of paper, babe. 10 times itself is going to give you 100, the number that's under the radical. Let's do the next one. When you have a calculator, 11 times 11. Does anybody know what that's equal to? 121. Good job. 121 is a perfect square. What is the square root of 121? What's the square root of 121? 11. Why? Because 11 times itself gives you the number under the radical, which is 121. The opposite of squaring a number is square root. Just like the opposite of addition is subtraction, and the opposite of subtraction is addition, the opposite of multiplication is division, the opposite of division is multiplication. So the opposite of squaring a number or multiplying a number times itself is finding the square root. They undo each other. Okay? Squaring a number and square root, they undo each other. Like addition and subtraction undo each other. Multiplication and division, they undo each other. Okay? Let's do the next. Let's find the next perfect square. 12 times itself. What's 12 times 12? Very good. 144. 144 is a perfect square. What is the square root of 144? 12. Because 12 times itself, 12 times itself is equal to 144, the number under the radical. Let's make another perfect square. Casey, you writing this down, baby? Okay, good deal. 13 times 13. 169. Good job. 169 is a perfect square. What's the square root of 169? 13. Okay, now I'm going to start calling individuals, okay? We got 14 times 14. Alexis, what's 14 times 14? 196. 196 is a perfect square. Alyssa, what's the square root of 196? What's the 14? Because 14 times itself gives you the number under the radical 196. Let's make another perfect square. Let's do 15 times 15. Enrique, what's 15 times 15? Very good. 225. 225 is a perfect square. Carter, what's the square root of 225? Very good. It is 15 because 15 times itself gives us the number under the radical, 225. Let's make another perfect square. 16 times 16. Arturo, what's 16 times 16? Type it in, babe. 256. Good job. Make sure you're writing it. You writing it down? 256 is a perfect square. What's the square root of 256? Jessica? What's the square root of 256? 16. Very good, babe. Because 16 times itself gives you 256. Let's make another perfect square. Anybody need me to pause? Okay, I'll wait. All right. Let's do another perfect square. 17 times 17. What's 17 times 17? Atiana? 289. Very good. 289 is a perfect square. What's the square root of 289, Kason? 17. Why? Because 17 times itself will give you the number under the radical, 289. Let's create another perfect square. 18 times 18. Angel, what's 18 times 18? 324. 324 is a perfect square. Okay? What's the square root of 324, Langston? 18. Why? Because 18 times itself will give you the number under the radical, 324. Let's make another perfect square. 19 times 19. Imari, what's 19 times 19? 361. Good job, babe. 361 is a perfect square. What's the square root of 361? Nia? What's the square root of 361, babe? 19. Why? Because 19 times itself gives you 361. Let's make or create another perfect square. 20 times 20. Hayden, what's 20 times 20? 400. 400 is a perfect square. What's the square root of 400, Haley? 20. Why? Because 20 times itself will give you the number under the radical, which is 400. I'm going to pause and then we're going to do cube roots. Jessica, you okay, babe? You good? Okay. All right, so now we're going to make perfect cubes, okay? Going to make perfect cubes. Okay, so to make perfect cubes, that means we're going to multiply a number times itself 3 times instead of twice. Cube is 3. That means it's to the third power instead of to the second power. Square is to the second power. Cube is to the third power. So let me show you that in the calculator. Your square root, if you type in 7 and you want to square it, you can go to math and you see number 3, you can press 3 and it'll square it. Oops, sorry. I did the wrong one. 7, this is x squared right here to the second power, okay? Or 7 math to the second power. Oh, they don't have second power on here, so you have to just use the x squared. Okay, to the third power, you could do 5 math, and 3 is to the third power here. You can choose the 3. Or you can do 5. You see this caret key right here? This is your exponent button. When you press the caret key, the number that you put after that is the exponent. So you can put to the third power, and that'll give you the same thing. So it's 2 ways to do to the third power. I can do 7 to the third power. I press 7, math, and number 3 will give you to the third power. Or I can press 7. This is called a caret key. And after I press the caret key, I can press 3 here. And that'll give me to the third power. Same thing. Okay? All right, so let's do those. Now you know how to do to the third power. 2 ways to do that. So let's make our first perfect cube. We got 1 times 1 times 1, or 1 to the third power. What's 1 times 1 times 1? 1. So 1 is our first perfect cube. This is how you write cube root. You do the same little square root, but you put a little 3 in the corner. This is cube root. Same square root symbol, but put a little 3 in the corner. What is the cube root of 1? What can we multiply times itself 3 times to give you 1? 1. Very good. So 1 is your answer. So cube root is saying what number can be multiplied times itself 3 times to give you this number that's under the radical. And 1 can be multiplied times itself 3 times to give you 1. Let's do another perfect cube. 2 times 2 times 2. Okay, or 2 to the third power. What's 2 times 2 times 2, or 2 to the third power? 8. 8 is another perfect cube. 8 is a perfect cube. Let's do the cube root of 8. And Ms. Reyes, how do you type in the cube root of 8? This is how you do that. You're going to go to math, and number 4 is cube root. So you press 4. This is the cube root symbol, and you type in 8. What does that give you? 2. Why is it 2? Because 2 times 2 times 2 gives you the number under the cube root symbol, 8. So the answer is 2. The opposite of cubing a number is cube root. The opposite of cube root is cubing a number. All right, let's do another perfect cube. 3 times 3 times 3. What's 3 to the third power, or 3 times 3 times 3? Type it in. 27. 27 is a perfect cube. Are you okay, babe? Okay. 27 is a perfect cube. So now we're going to find the cube root of 27. It is 3. Very good. Why? Because 3 times 3 times 3 is 27. Come on, Jaden. As soon as you get in, you want to hop, skip back to it. Okay, baby? Take out your interactive notebook, sweetheart. Composition notebook. All right, so let's make another perfect cube. 4 times 4 times 4, or 4 to the third power. What's 4 to the third power? 64. 64 is a perfect cube. Let's do the inverse of that. Let's find the cube root of 64. What's the cube root of 64? 4. Why, Miss Reyes? Because 4 times itself 3 times is equal to 64. Cubing a number, the opposite of cubing a number is cube root. The opposite of cube root is cubing a number. They undo each other. Let's make another perfect cube. 5 times 5 times 5. 125. Very good. 125 is a perfect cube. The opposite of cubing a number is cube root. So let's find the cube root of 125. What's the cube root of 125? 5. Why, Miss Reyes? Because 5 times 5 times 5, or 5 to the third power, is equal to the number under the radical. Okay? I want to see if you can do all the way down to, let's do all the way down to 10. We don't have to know as many cube roots as we do square roots. So let's try and see if you can do all the way down to 10, and then I'll go over it to see if you got those right. So I want you to try to make perfect cubes up to 10. Use your calculator. All right, let's see. We got 6 times 6 times 6. What did that equal? Say again. 26. How do we type that in? We type that in as 6. We can say caret key 3, and that gives us 216. 216 is a perfect cube. What is the cube root of 216? What's the cube root? So what is the cube root going to be equal to? 6. 6. Now let's make another perfect cube by doing 7 to the third power, or 7 times 7 times 7. So that's 7 caret key 3. And what does that give us? What's 7 times 7 times 7? 48. 343. 343 is a perfect cube. The opposite of cubing a number is cube root. So we're going to do the cube root of 343. Ms. Reyes, what button do I press to do cube root? Anybody remember? Math. And then what number? 4. And type in 343. And what does that equal? 7. Why is it 7, Ms. Reyes? Because 7 times 7 times 7 is equal to the number under the radical, 343. Let's make another perfect cube. 8 times 8 times 8. Okay, that's 8 to the third power. 8 caret key 3. What's 8 to the third power equal to? 512. Very good, Neil. 512 is a perfect cube. Now let's find the cube root of 512. Okay, to type in cube root, math, number 4, and 512. Enter. What does that give us? 8. Why, Miss Reyes? Because 8 times 8 times 8 gives us this number under the radical. Remember, they're inverses. Cubing a number is the opposite of cube root. They undo each other. Let's make another perfect cube. 9 times 9 times 9, or 9 to the third power. What's 9 to the third power? 729. 729 is a perfect cube. The opposite of cubing a number is cube root. They undo each other. What's the cube root of 729? 9. Why, Miss Reyes? Because 9 times 9 times 9 is 729. The last one. 10 times 10 times 10. What does that equal to? 1,000. It's 3 zeros. 1, 2, 3 zeros. 1,000. 1,000 is a perfect cube. The opposite of cubing a number or raising a number to the third power is finding the cube root. What's the cube root of 1,000? 10. Any questions? Are y'all good? All right. Okay, you can put your notebook up. Is anybody still copying? You are. Go ahead, baby. Here, you can use my notebook and make sure. I'll hand it to you so you don't have to get up. All right, you got the foldable. We got only a couple minutes. So we're going to get started on the foldable, but we're not going to finish the foldable. So we're going to put it in what section of our folder? Work to do. All right, so put this in front of you. Miss Reyes is going to fold both sides of the foldable in. You see how I have it perfect squares on this side? Fold this in. Thank you, Miss People. You too, babe. You see how I'm going to fold square root into that solid line? And I'm going to fold cube into, fold it in, just like this. So it looks like this. You got square root, cube root. So let me hold it up so you can see it. It looks like this. Fold them in, just like this. Very good, Casey. Colton, do you see how I folded it in? Fold it into the solid line in the middle. Fold it into the solid line in the middle. Pause. All right, so this is what I need you to do. See if you can do this on your own. What perfect square is equal to 1? 1 is. The square root of 1 is equal to 1. What perfect square is equal to 2? 4. The square root of 4 is 2. What perfect square is equal to 3? 9. Okay, 3 times 3 is 9. Okay, the square root of 9 is 3. What perfect square root is equal to 4? 16. And see if you can fill this in, okay, all the way to 20. Okay, all right. Then after you do that, I want you to put this in your folder. Work to do because we're not finished. And put your calculator back. Put your calculator back. Okay? All right.